All right, guys, good morning. So, in this session, we're going to be looking at the Kotlin programming language, which is the official programming language for Android development. Now, initially it was Java, but in 2017, Google announced official support for Kotlin in Android development, and in 2019, it became the preferred language for Android app development. So, Kotlin is the official language for developing Android apps. So, that's why we're going to be working with the Kotlin language, right? So to do that, now we don't want to interfere with this our app. Just in case you have an existing app and you want to run raw Kotlin codes, right, inside your application folder. So what you need to do is just create a new. Come to click on this package, or you can just come to this main, the com.example dot whatever is the name of your app. So just click on it, right click on this folder, go to new, then click on Kotlin, then you can just call it, let's call it raw Kotlin dot kt. Now kt means that it's a Kotlin file, right? That's the extension. So any file with the extension .kt is a Kotlin file. So the very first thing we're going to do is we're going to look at the different data types in Kotlin. There are numeric data types, there are string data type, there are Boolean data types, and there are other data types as well. But in this session, we're going to focus on numerical data types. So we're going to be working with only numbers in this session. So in subsequent sessions, we'll look at the other data types. So the very first thing we want to do is to now, before you can run a raw Kotlin code, you have to create a main function. Now function will be treated as a separate topic, right? But for now, let's just create a basic. This is the main function. So this is how to create a main function. So fun is short for function, then we have the main, then the curly bracket, and then the curly bracket. So everything we are doing is going to be inside this curly braces or curly brackets. So the first thing we need to do is to create a variable. Now, a variable is simply used to store different types of data, right? A variable is just generally speaking, in programming, a variable is referred to as a like a container that stores data, right? So now to create a variable in Kotlin, there are two ways. It's either you use val or var. Okay, var x is equals to 15, or var y is equals to 10. Okay, so these are two methods of creating. Now this val is, we use val when we want to create a variable that has a fixed value, right? That means the value cannot be edited or changed, so is immutable. Why this is mutable, I'll explain this in a second. So the value of x is immutable, so that means we can't assign a new value. Here 15 has been assigned to this variable x, right? So the name of the variable is x. I can also change the name to let me say number one number one, or let me just call it first number. Yeah. Oh, sorry. Let me call this second number. Now it's up to you to decide the name that your variable will bear. Yeah. So um so what's the next thing? Okay, I just want to quickly demonstrate the difference between the two. Now I can come down here and say first number is equal to um 10, or let's say 11 or 12. Now when I do this, I'm going to get an error. You can see that there's a red line here that says val cannot be reassigned. So it means that I can't change the value of this, right? But in the case of second number, because it's mutable, I can now come here and say second number. Sorry. Yeah. So I don't get any error because var is mutable, so I can change the value. Now I can come here and print Now, print is used to display data in this console. You can see the console here. Right. So let me print second number. Let me print the initial. This is the initial value, and this is the final value. Let me quickly comment this. Now, I let me quickly chip this in. So to comment a code means to deactivate a particular line of code. You don't want the code to function again. You don't want the compiler to read or execute that code. So all you need to do is comment it out by putting two forward slashes in front of that code, right? So you can see this code. The compiler will compile or execute this code the way it is now. But if I add two curly brackets, two forward slashes, this has been commented out or deactivated, right? So let's just quickly deactivate it. So let's print display. Like I said, print is to display print ln, that's print line, print ln together, no space in between. So I want to display second number on the terminal. So now to run it, I can either use this play button or this. Both of them carries out the same function. So I just click on this, run. Let's just wait for it to run. Okay, so second number is printed. We have 10 in the terminal because that's the value. Now, if I come here, let me uncomment this. So I've changed the value of second number to 12, right? So let me quickly copy this, or let me just cut it and put it here. So the way the compiler works is that it starts from line 1 and start executing down, as in downwards. So this will be executed first, right? 10 will be stored in second number. Now, because we have changed, so when the compiler gets to line 11, so it sees that a new value has been added, has been, yes, assigned to second number. So that new value will now be printed. So we will not have 10 in this terminal again. Rather, we're going to have 12. So let's quickly just confirm that. So you can see 12. So why were we able to change the value? Because we are using VAR. So VAR is mutable, VAL is immutable, right? Okay, so let's just quickly. So there are, when in Kotlin, right? If you are working with numbers, you must consider the fact that they are whole numbers and they are decimal numbers, right? Now the whole numbers, there are basically four types of whole numbers. There's byte, there's short, there's integer, and there's long. Okay, so let me just quickly demonstrate so I can comment all of this. Right. So to comment an entire line of code, right, all you need to do is highlight it, then control forward slash. You press control first before forward slash once, and then all that entire selection will be commented out. So everything has been deactivated. So we have just our simple. So you don't have to bother about cramming all of this. I'm going to create a cheat sheet, right? And I'll attach it to the description of this video. So you don't have to try to cram it. So we have bytes, whole numbers, whole numbers. So we have bytes, right? Now byte occupies 8 bits, right, of memory. That means when you create a variable that um, stores a byte, so the compiler is going to a memory space of 8 bits is going to be created for that variable. So it only occupies 8 bits. Now you don't really need all of this, and you might not even in your code you might never use bytes, right? Because basically um, the particular whole number type that we're going to be using in Kotlin, right, is integer. That is the default whole number type, right? So bytes is we use bytes when there's going to be like consideration for memory optimization and the others. I'm going to explain that later on. So this is the range -124 to 127. Right. So then we have short. Short occupies 16 bits. Alright, so let me quickly comment this so that it doesn't flag an error. Short is actually is starts with uppercase and is in between 32,768, negative 32,768, and positive 32,767. So this is actually the range of value, right? So if you create a variable that is between 128 and 127, so Byte can only store this particular range between -128 and 127, and it only occupies 8 bits on your system memory. Short stores value that ranges between um, -32,768 and 32,767. Right now, int, this is the default whole number type in Kotlin. This integer short is actually written as int, that's int. So int occupies 32 bits. Sorry, I said 32 bucks. That's interesting. So I'm actually copying this from my phone where I stored this value. 83648 2. Okay, let me add 2 so that it's clear. To this particular value, the positive of it, or -1. Yes. So int can store from negative this to this, right? So anything beyond this is going to see it as an error. That's if you are creating an int variable. I'm going to demonstrate that once I'm done with this. So just stay with me. So then we have long. Long occupies 64 bits. Yes. Then the range is -922372036,854. Yeah. Oh no, that's not. We're not done. Very long. As I called long. Yes. So to this, from this to this to 7. Okay, so I think that's the maximum. So anything that exceeds this, we need to import an additional package from Java, right? A particular Java library that helps us to, not a library, particular Java module that helps us to address that, which I'm going to explain now. So let me just quickly demonstrate it. So let's say we have an x variable, right? I want this x variable to be an integer or to be a byte. So this is what we are going to do. Now we can just come directly and say 127, right? That's the simplest way to create a variable. But at times, I think there will be need for you to specify the data types. Not in every case, but there are some cases where you just have to specify. So this is byte. Now byte stores from 127 to -128 to 127. So if I come here and say and store something that falls within the range, so I shouldn't have any issue. uh okay, let's say 10. So that's it. I'm wondering why it's flagged an error. So the thing is, like I said, byte is used to, in the case where you want to optimize the computer memory, because the way it works is it creates the required space for that value, right? So in the case where you are considering, as in optimizing your the memory of your application, that's where you use byte. But in a conventional Kotlin application, you might never use byte because, sorry about that, because the default whole number type in Kotlin is integer. So if I come here and say, let's say, and impute a value that is greater than the range, the maximum range. So I get this error that says in the literal integer literal does not conform to the expected type byte. So that's it. Same with short. Right? Let's say we have short and we now put a value that is greater. Let's say 9 million. So I get this error. But when I decrease it to 9,000, so it falls within the range, so I don't have any value. So now the thing is, like I said, it's not in every case that you need to specify the data type. Kotlin has a way of inferring, right? For example, if I create a variable and call this 10, by default, Kotlin sees this variable as an integer. Now, if you check, you can see if you hover over this, you see this pop-up that displays the data type. So it shows you that x is an integer. So despite the fact that the value of x, which is 10, falls within the range of a byte, Kotlin sees it as an integer by default, unless we specify that this is a byte by adding the type here, just like we did previously. So that's the only case where Kotlin is going to treat it as a byte. So when we hover over this, sorry, let me just quickly. So it sees it as a byte, but if I just create it in a simplified manner, it's treated as an integer by default, right? And that's how Kotlin works. So and then we have long, right? Now long is so the two whole number types that you are going to be using a lot in your programming, as in while developing applications with Kotlin is integer and long, right? Long is used for humongous values that are very large, and then int is used for int is the default whole number type, right? So now if I come here and create another value that exceeds the range, the maximum range of an integer, Kotlin is going to automatically treat it as a long, right? So you can see why is a long, right? So if I decrease the value such that it falls within the range of the integer, so Kotlin treats it as an integer. So that's the way Kotlin works. So I don't need to specify that this is a long. I don't need to come here and type this. I don't need to. I don't have to. Kotlin automatically treats it as a long, right? So if I come here, is a long, and if I delete it, Kotlin is called infer. Kotlin will infer, right? That this will infer the data type of that particular of the data that is stored in that variable. So you can see that is a long. So that's the way Kotlin works. So just pay attention to this integer and long. Forget about the short and the bytes for now, because you rarely use it. That's if I thought you use it. Okay, so val what's it called? Int and long. So let's proceed. Now, what if you have a value that is okay? Okay. Let me quickly demonstrate this. Now, if you want to make your because if you observe, this is a huge, a very huge integer, right? But we are not really sure what, as in how to name this particular value. So there's a way to do it in Kotlin, and that makes it easy. So it helps you to like structure your add value and make it very presentable and easy to read and easy to understand. So this is how to do it. More like you're using commas in mathematics. So in this case, we use underscore, right? Underscore 1,000, underscore 1,000,000, underscore 1,000,000,000, yep, underscore, sorry, 1,000,000,000,000. Yeah. So this is just like a way of rearranging that particular value, right, to make it look presentable and easy to read. Right. Okay, so there's now you can Also add L. L means long, right? But you don't have to, because once that the value goes beyond the maximum value of an integer, Kotlin will automatically assign the long type to that uh, what's it called, to that variable. So, but if you check some Kotlin codes, you see something like this. It's actually the same thing, right? It's the same thing. It's the same thing as this. Adding an L is the same thing as this. There's no difference. Is that you do it this way, right? Or you do it this way, or you just put an L, so it's a long. Now, just in case, now you can convert an integer to a long, even though that the even despite the fact that the value is not large, right? You can still convert it to a long. That's just the beauty of Kotlin. So let's say this is 1000. 1000 is ideally it should be an integer, but I can convert it to a long by simply adding this. So sorry. So I've assigned long to it. So Kotlin is going to see it as a long. You can see it's a long. Or just to add L behind it. Then when I hover, it's treated as a long. So that's just it. So okay. Um Now what about um if we have a number that is greater than long? Because there are some numbers that exceeds this. So how do we do that? Now we need to 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 do that. We need to import a module, right, from Java Math module. So we import a module called big integer. Now this is how to do it. To come to this the top here. That's we're not doing it inside the main function, we're doing it outside top level. So then import java dot math sorry dot big integer. You can see. So this is what we use to address the cases where we are working with a number that is greater than long. So I can come here. Um, okay, let me quickly create that value. Um, let's call it huge. Let's just call it huge number, and let's create a very very huge number. So let's um, you can see this number is quite huge. So we have an error here. The value is out of range because Kotlin doesn't know how to deal with this. So in order to do that, we use this. We import this, and okay, and this is how to address it. We just put this big integer in front, put it inside. Okay, so cut this guy. Let's cut him. So and we'll put it inside this quotation mark, right? So that's how to work with humongous data. Okay, so then we move to decimals. Now in Kotlin, decimals are basically grouped into two. There is float and then there is double. Now double is actually the default decimal value, just like int is the default whole number value in Kotlin. So what's the difference? Now float, let me quickly spell. This is float. Float is spelled as F, and double is spelled as double. So float actually gives you the decimal value to about 6 or 7 digits. Right, yeah, digits. While double is going to give you that value to about 15 digits. Now, the digit includes both the number before the decimal and after. 15 to 16 is about 16, yes, 16 digits. Now, what about if you have a decimal that exceeds this? Now, just like we did with big integer, so there's also big import java dot math dot big decimal. So that's what we use. So we now do it the same way we did with with big integer, just the same way. So, but I don't really want to delve into that. So let's just move to the next step, which is algebraic method. Now, algebraic method refers to how to carry out simple mathematical operations in Kotlin. That's addition, subtraction, multiplication, and division. So let's just quickly look at that. So we have two values, x and y. So let's say val sum of x and y is equals to x. So we use plus, right, for addition, right? Then we create another, sorry, val the difference is equals to x minus y. So we are going to print out all of these val products. Now we know product is the multiplication. So multiplication of two or more values. So s we use star x star y. Now if you want to refactor your code, because you can see this my code is not well arranged, so I just come to refactor. Uh, Code. Okay, format code, reformat code. So when I click on this, my code is well arranged. Right, looks good. So that's just how to do it. You don't need to learn the shortcut. It's easy to. I think there's a short thing for it. Okay, this is a shortcut. Control alternate L, but you don't need to use it since all you need to do is just to click on this, go to code and click on format code. So I think that's even easier than using a shortcut. So let's look at quotient. Now quotient will return one. Let's call it cool. Quotient simply means the result when two numbers are divided. Let's call it cool. So we have a slash b. Sorry, x slash y. So that's the division, right? So it's going to return the whole number, right? Then what if we want to return the remainder? So we use percentage. So let's call this more, or let's just call it remainder is equal to x percentage y. Yeah, it's actually called modulus, but we'll just call it remainder here. So let's print out all of these. Print line. Let's use a text this time around. Sum of x and y is. So now there's a way we can pass this, what's it called, this variable inside this text, right? Now how do we do that? We use the dollar sign. Yeah. So so what it does is that it takes the value of this and puts it here. That's just simple. So copy all of this, and then I want to print each answers on a separate line. Products a difference between uh y is, then print, let's just call it difference. Yes. Yeah, let's just call this sum, make it simple. Print uh, sorry, small letter n. um what else do we have? We have the product. Sorry, I diff. Yeah, product, product, and then quotient. Print line quotient. Yeah, cool. Let's type this in for quotient. And print remainder, remainder rem. Okay, so let's just quickly run this guy here and let's see the result we got. See what we got. All right, so we have the sum is 7, difference 1, product 12, quotient 1, remainder 1. So that's it. Right. So then we have comparison operators. Now these are, we call these algebraic operators. Algebraic, sorry, algebraic operators. So let's look at comparison operators. Is this spelling wrong? Okay, comparison. Sorry. Yep. So let's comment all of this. Control, we select everything, then control forward slash to comment. So we are still using, let's see. Okay, we can leave this. We are still using x and y. So comparison operators are used to compare two values, right? As the name implies. So so we print, let's just print it directly instead of creating a variable to store the answer. X is x greater than y, right? So now let me quickly write it. So this is greater than, sorry, what am I doing? This is greater than, this is less than, just like mathematics too. And this is equal to, not one equal but two. One equal sign is used as an assignment operator, is used to assign values, but double equal sign is used to compare two values, whether they are the same. This is sorry, equal to, and then we have not equal, which is this. As we have the exclamation and equal to, not equal to. Okay, so that's it. So it says, let's quickly print equal to, greater than, less than, right? Forget about the yellow line underneath. It's just telling us that this value is always true because x and y are constants. They are not variables. They are actually variables in programming, but what I mean is that the value is fixed, right? Okay, so equal to, and then not equal to, not equal to. So let's just print all of this and see how it works. Okay, so this is what we have. We have true, false, false, true. That means x is greater than y is true because x is 4, y is 3, so x is greater than y. X is less than y is false because x is 4 and y is 3, so x is not less than y. X is equals to y is false, they are not equal to. X is not equal to y is true. So these are called comparison operators, right? Okay, and also in Kotlin, there's, aside from this Java module, right? This Java math module, Kotlin has its own math module that we can make use of, which, so it's called Kotlin, I think Kotlin maths. Yeah, maths. Dot. Now this is how to import everything. We want to import everything, right? All of the methods, all of the functions that are in this particular module. So what we are saying is import everything. Star means everything in Kotlin and in some other programming languages like Python, even SQL. So we are saying import everything from Kotlin.math. So it's going to import everything. So there are quite a number of, so let's quickly comment this. Quite a number of predefined values and functions that we can use there. So for example, there's pi. Let's call it new pi. There's pi, that's pi. So yeah, so this is pi in Kotlin.math. So we can print it out. And this is the same thing as pi in mathematics, right? Okay, you know what? Let's just create a variable and save it. Well, let's call this pi. It's equal to pi. Yeah, pi. Okay, so I print pi. Good. So it's going to give us 3.1. What's the value of pi again? I've actually forgotten. 3.142 something. Yeah, 3.1425. So that's it. We imported it from this Kotlin.math. Okay, so there are several methods also that we can use. There's the square root method that helps us to find the square root of a particular number. So let's say val, let's call this a is equals to 25, a new variable, and then we want to find the square root of this a. That's so this is actually this is the we call them methods as predefined functions. So it's actually square root. That is yeah. Okay, this is it from Kotlin.math. You can see square root from Kotlin.math. But to make our code neat and uh, yeah neat, so we can just create a. What am I doing? My mind is elsewhere. Square root. We can just create a separate variable that will store the answer. Square square root. Okay. So we want to square root a. Why is this still giving me this? SQ. Okay, yeah, that's it. Oh, okay. So let's change this to double. Yeah, not zero. Okay. So why now the reason why it gave us that because we actually we created a variable that is an integer, and the answer when we find the square root this particular method or function we always return a double or a float. So and that's why it gave us that error initially, right? So we have to change it to double so that the answer will correspond to the double that this um, method returns. So we can now go ahead and print this out. Square root. Let's quickly comment. Okay, I think I've commented the first one. Okay, 5.0. So let's use something else. Let's say 30. So it's going to give us the. See now, since we are using double, so the answer will be displayed in about 15 to 16 digits. So we can count it to confirm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, that's 16. Now, if we change it to float, we're going to have just, um, sorry, where is it? Okay, let's just quickly do something. Change it to float and put an F in front. Okay, so it should work this way. And then but the answer will only come in displayed in just 7 digits. Okay, you can see just seven. 1, 2, 3, 4, 5, 6, 7. So that's the difference between double and float. So for precision we use double, right? Yeah, double, double, yeah. And then we'll come here and put a zero in front. Point zero. So that's that about that. So then we also have we can round up this value, right? We can create there's a method that helps us to round up values to either yeah. So let's round up this value. It's called round. Let's call it round answer. We want to round up this square root. So we use round function. Square root. Square root. Yep. So answer, and then we display. Let's quickly print it out. Round answer. So run this. Okay, so rounded it up to the nearest whole number. Then we have there are quite a number of methods that are in the Kotlin.math module. So let's just treat one more, and then that'll be all for now. So I think there's also power, right? Power. How do we use that again? Okay, let's just call this power equal to 2.0. Right, so want to find 2 raised to power 3. Want to find the value of 2 raised to power 3 rather. So we have 2.0 dot power, that's how to do it, POW, and then 2 raised to power 3. Yeah. So let's print power. Can comment this print statement so that it doesn't. 2 raised to power 3 is 8. So we should have 8 in the terminal. Okay, so that's it. So that's okay, and then we also have, I forgot to mention, then we also have random variable. Now this helps us rather to generate random values. Now to do that, we need to import the module. I think it's import kotlin dot random or random dot capital letter. Yeah. So this is how to do it. Random dot random. So we can use this random to generate random integers or random decimals, right? So well, let's call this int random or random integer. How do you spell? Okay, this is integer. Yeah, random dot next int. So this next int is used to generate an integer, that's a whole number. So then we can specify the range. We want it to generate a whole number within this particular range, that's 0 and 100. So that's how to specify the range. Then we can also generate, let me just do everything together. Random decimal. Okay, let me call this random dec is equal to random dot next. We can either generate a, you can see there's next float and next double, but let's just generate. There's also next bit, but since we are not using, sorry, next byte rather. What's this again? Let me just type it. Okay, next bit. Okay, and there's also next byte. There's next double. There's next long. So we can use it to generate any kind of random value that we want. So, but let's just generate random double. Right. So let's specify the range from zero. Sorry, from 0.0 to let's say 100.0. Right. So because we are generating a double, so the range has to be a double, right? Here we are generating an int, so we use an integer. We don't, and like I said, double signifies, double actually stands for decimal values, double and float. So let's quickly print out. Let's comment this print statement. Let's print out this print line. Uh, so if you notice, I use either print line or print, right? So they are both basically the same thing, right? So let's just um, hold on to that for now. When we start programming proper, we're going to look at different ways to display information on the terminal. There's also log, right? Log is kind of different and a bit advanced. Log is what we use for our application majorly. We don't use print statement for our application. So if we want to get information in the terminal or in the logs. So we use log. But for now, we are just using print because we are writing raw code. So print or print line. Right. Okay. So print line. What print line does basically is that it displays that particular print statement on a separate line, right? So that's what it does. So let's just, and that's what is recommended. So let's just quickly use that. Random integer. I even spelled it as random. Random. Interesting. Print line random decimal. So it's going to give us. So we'll run this several times so that just to confirm that it generates at, as in when we run this code, at every point where we run the code, it generates a new value. Yeah. So okay, so for random integer we have 66, then for random decimal we have 43 points, blah blah blah. So let's run it again. It's gonna give us a new value. Okay, so in this case we have, let's run it the last time. Okay, you can see it generates a new integer and a new decimal when we run the code. And so that's how to work with numbers in Kotlin. So thank you very much for watching. I'll see you guys in the next video.